Alright, it is time for the second half of this on the back. But before that, here's a picture of my dog. Oh, she's so cute. Yellow lab. Her name's Callie. We love her. Aw. Yeah. Okay, back to math. We have an example followed by one where you get to do. Just like the previous video, I'll have you pause right here to try it, and then I'll show you what the answer was. So up here, graph the following equation. 2x plus y equals 5. The first thing we are going to do is to get it in y equals mx plus b form, also known as slope-intercept form. So the 2x plus y equals 5, this one is luckily pretty straightforward for us. To make it say y equals, we just need to get rid of the 2x, like that. So y equals other stuff. So to get rid of this positive 2x, we are going to subtract 2x. That way it goes away and we end up with y equals. So I'll just put it down here, y equals. And we do want the x part first, mx plus b, so we do want the 2x and then the 5, so negative 2x. And then since that's a positive 5, we will put plus 5. So that is our slope-intercept that we are going to be using. And this 5 right here is the y-intercept. Once again, it's very important to note that it is the y-intercept. Since this is the y-axis, the 5 is going to be on the y-axis. So you want to put a point at 5 up or down. In this case, since it's positive 5, once again, it is up. 1, 2, 3, 4, 5. Right? Y-intercept. Please do not put it over here on the x-axis. It is the y-intercept. Here it is a negative 2. Since it is a whole number, that is the same thing as negative 2 over 1. In which case you'll be going down 2 and over 1. And you will always be going to the right one. Please remember it's always to the right one. So down 2, because it's negative, over 1. So down 2 over 1. And you can keep going, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. If you feel like it, you can continue the pattern. Instead of going down 2 and over 1, you could always go up 2 and backwards 1, up 2, backwards 1, up 2, backwards 1, up 2, backwards 1. Not super useful right now, but when we get into piecewise functions, it's useful to be able to do more than one point. So I just thought I'd do it. Connect some dots. Put some arrowheads. We got ourselves a line. Domain and range should be everyone's favorite question, because lines, they go left forever, they go right forever, they go up forever, they go down forever. The only exception is either a vertical line or a horizontal line, but since we're not dealing with those at the moment, domain and range is just always going to be negative infinity to positive infinity. As you can see, this is pointing to the left and the right. So domain negative infinity to positive infinity. It is going down to negative infinity, up to positive infinity. So negative infinity to positive infinity. Or if you feel like it, you can just do the symbol for all real numbers. Either one. End behavior. There are two ends. This is the one on the left. The left side has an arrow pointing up. So it is going to go up to positive infinity. Over here, this arrow is pointing down. So as x goes to positive infinity, f of x is going to negative infinity. Remember, you have two choices in lines. Either it's going up to positive or down to negative. As for the x-intercept, you can kind of figure it out here. Boom, boom, boom. Right there is the x-intercept. It looks like it's 2.5. It turns out it is exactly 2.5. I'll put 2.5 comma 0. If you feel like it, you could also do it in fraction form, which is 5 halves comma 0. But it is actually exactly on the 0.5. Now, if you don't trust the way you look at it, which, in some cases you don't want to, if the slope was like 3 or negative 3, it would be more difficult to know by looking at it. The algebraic way to find it from the equation is that to find an x-intercept, you make y 0. And to find a y-intercept, you make x 0. That's just how it's generally done in any function ever. So if I was to go here, like best back to the original, 2x plus y equals 5, to find an x-intercept, I'd make y 0. So if this y was 0, you would just have 2x equals 5. Which, you know, when you do algebra and stuff, you get 5 halves. Woohoo! Yeah! Hot jazz hands. Woo, celebrate. Okay. Yeah, I know I'm weird. Whatever. Over here is the U try. So go ahead, press the pause button, and give it a shot. Coming back for the answer, we over here want to get y by itself. So we are going to have to subtract the 6 over to get y by itself. So subtracting the 6, we would get 2x minus 6 equals 3y. Once again, that is from subtracting 6 to get rid of it. So 2x minus 6, 3y. 2x minus 6, 3y. I'll just switch them now, because why not? So 3y, don't know why it looks like an x. 3y equals 2x minus 6. And if you divide by 3, you will get, let's just put it down here. Y equals 2/3 x minus, that's 2. Boom. Boop, 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 boop. That minus 2 says to start at minus 2. 2 over 3 means to go up 2 and over 3. Up 2 over 3. Down 2, backwards 3. Down 2, backwards 3, etc. Over here, this is pointing down to negative infinity. This is pointing up to positive infinity. It looks like it didn't ask for the x-intercept, but as you can see, it's right there. It was actually a dot when you used the slope for 3, 0. So the x-intercept is 3, 0. I'll just make a remark. And then the domain and range is, you guessed it, negative infinity to positive infinity. Woo! Woo! You excited yet? I know you're excited. Why do I even ask? No, really, why am I even asking? I can't even hear your answer. Oh. Right, okay. Well, that's it. I'll zoom out a little bit, I guess, in case you need to see the worksheet again, but there you go. Have a good one. And here's my dog again. She's so cute.